So today we are going to do a game. The game's acronym is RPS, three words. Start with R, second word start with P, and third word start with S, and it's a game.
Rock, paper, scissors.
Yes, very good. Yeah, rock, paper, scissors. Yeah, yeah. So today we are gonna do apparently it's a text-based, right? We're gonna do a text-based rock, paper, scissors. And our program is gonna play with a human, right? So then we're gonna have human come up with what the human wants to play, right? Human's gonna maybe provide the input. Is that a rock or paper or scissor? And our program also gonna be trying to generate a play out of rock, paper, and scissors. And I'm going to show you how do you randomly pick something to play. So that's what our program is going to do. We randomly going to decide what to play, and we have the user enter something for his or her play, and then our program going to compare, and we're going to see who wins and who loses. Okay. So without further ado, let's go ahead to dive in. So go ahead to create a class, and let's call that class, you can call that rock, paper, scissors, or you can just call that RPS, doesn't matter. So I'm gonna just call that RPS. And now we're all set to go. Okay, write our main function, public static void main, string, bracket, square bracket, argv. Okay, now let's try to step back and think, oh my God, I have so many things to write, right? We're gonna just like try to think through what will be the steps that we need to implement, right? So let's see. We want to first greet the users, right? Because you want to tell the users what he or she need to do, right? You greet the user, maybe we're gonna say welcome, blah blah blah, right? Then we are gonna tell the user to provide the input, right, which is the play, right? So ask the user what to play, right, and give them some instruction, right? Instruction will be just probably, you do R, rock, maybe we want to say enter rock, paper, or scissor, whatever, right? So that would be the instruction you want to print. Right, so that's our second step. Then you want to do what? The user entered their play. Now you want to try to generate our play, which will be the random generating thing, right? So you want to randomly generate, let's just call that robots play, right? Robots play. Okay, so this part of step 3, I'm gonna have to show you guys how to do it. Okay, why is it right? And then what? Then you have to play. We can compare, right? Then we're gonna compare to see who wins. And this part is will be a little harder because we're gonna do conditional flow, and we're gonna actually have different scenarios. So we're probably gonna spend some time like dive into this step, right? Then you want to like tell the users who wins, and maybe what did the robot play, right? Just kind of provide information, and then we're done, right, guys? So for each round of play, this is what we need to do, right? So how about for some of I think the easier step, I'm gonna have you try to do it, and then I'll catch up. How about that? You guys try to do step number 1 right now. How do you greet a user? Print out a sentence, say welcome to my paper, scissors, rocks game, right? And just do something like that. It's very easy. So go ahead to practice, print out a sentence, rather than I just keep writing things and you guys keep following. Because sometimes my students say, oh, wait, I haven't copied things down yet. And I was like, no, you shouldn't be just copying what I write. You need to proactively think and should be able to come up with a code by yourself. So just make sure you do that. Even if you are following what I do, don't treat it as a copy, because that's really not what we're here to do. System.out.println, welcome to my rock paper, scissors, game. Just like that. Now we're going to ask the user what to play. Right? So why do you guys do this? You need to create a scanner. I hope you remember how to do it. Create a scanner. Oh, actually here you need to, step number 1.5, you need to provide instruction, right? So here, we're gonna say, system.println, please enter rock, paper, or scissors. Okay, what do you want to play? Say, how about that? Is that clear? How about that? Yeah. Okay, so now you guys write this code that you take in user's input. You need to do scanner, right? 2 or 3 lines of code, depends on what you do. Maybe we're just gonna use the first letter to rather than processing the entire string. This is a string, right? A bunch of characters, those are string. But since they all have a different first character, we could just get a first character, and later on we're gonna do a lot of if else to compare, right? So we can just compare the character. So now you're gonna take input, okay? Then you're gonna take the first character. How do you take the first character? Okay, so what you do is that first you're gonna use a scanner, right? So define a scanner, give it a name. I usually call that SC, and don't forget that you want to import the scanner so you can use it, right? And then you're gonna take input. The input will be a string, and as we said, we're gonna just take the first character, so the data type will be char, right? And let's give this a variable name, which is gonna be the user's input. So we can call that, give it a descriptive name about user play or something like that. Right? You always want to name your variable in a descriptive way. Then you take input next, right? So next, remember you use next to take whatever user entered as a word. Then you're gonna say, okay, I just want to get the first character, first char. This means the character at position 0, which is the first position. So that is going to give us either R, character R, or character P, or character S.
And the A is capitalized because.
Camel case.
Oh, right.
Yeah, camel case, and this is part of the Java API. So this function is provided by Java. So you can't really say anything else. You can't just say, oh, character at. No, that doesn't work. See red. So this is really defined by internally from the Java API, just like this string line, just like this alt. And the Java API also use the camel case convention. That's why it looks like this. Okay. Right. So now we got a user play. Now, next step. Next step, we want to randomly generate what the robot wants to play, what your computer is going to be secretly playing, right? The user doesn't know. So here, so this is a little bit more complicated. There's some steps that are actually involved. So let me try to describe. Now, I want to evenly distribute, either R or P or S to play randomly, random, but evenly distributed, right? So usually whatever you want to generate, if you want to generate 3 different possibilities, then we're going to treat it as 3 numbers. So how about we say, I'm going to randomly generate 3 numbers, which will be 1, 2, 3, 0, 1, 2, doesn't matter. So let's just go with 0, 1, 2. So we actually want to randomly generate 3 numbers in this range. And later on, we're going to say if it's 0, then R, if it's 1, then S, if it's 2, then P. The assignment doesn't really matter, right? It doesn't matter. The mapping is not important as long as they each take 30% chance, 33% chance. So how do I do this? You do this by actually working through a bunch of steps. Okay, so let me try to Java have a function that goes like this, math.random. Okay, just like all these are Java API functions. So same thing with math.random. So we're gonna write a sentence. We're gonna say math.random, and this thing is actually gonna give us a double number, which is a floating number, right? A double number in the range of 0 to 1. This is our first mini step to do this, okay? First mini step. And you guys notice that I use square bracket for the left bracket, and I use parentheses for the right side. Why? Because this means inclusive. So this is just kind of convention notation that usually people use. If I do square bracket, I mean, it means inclusive. Okay, that means it could generate a 0. And if I do parentheses, this means not inclusive, non-inclusive, or exclusive, right? Which means it's actually not going to generate 1. It may generate like a number infinitely close to 1, maybe 0.99999, infinitely close to 1, but not 1. Okay, so this is how we describe the range like this. And that's what this line is going to give you. Okay, once we have this double, then we're going to do a multiplication. How about that? We're going to, let's call this D, right? It's maybe later on you're going to write code. If you want to write it now, that's fine. You're going to maybe call this a D, call this a variable D. So it's just for us to easily explain. Let's say it's called D. Now, if I do D times 3, what do you guys think will be the range of D multiplied by 3? The value of the range of D multiplied by 3. So D could be as low as 0. If I multiply by 3, it will be still 0. Yeah? And D could be as high as 0.9999999. So if you multiply by 3, that will be like infinitely close to 3, but not 3, right? So it will be 3 and parentheses, like that, right? So effectively, it will be 0 to 2.99999, like that. Now, if I cast it, if I cast this number, then what we get? We learned casting. Casting is convert a double number to an integer by chopping the decimal part out. So if I cast this result into an integer, what do you guys think will be the resulting range?
1, 2, or 3.
1, 2, or 3, almost 0, 1, 2, right?
Yeah, that's what I meant.
Yeah, I think that's what you meant. Yeah, it will be 0 to 2 because it's 2.9999. You chop it out 0 to 2, and now it's all inclusive. So that's really just 0, 1, 2, and that's what we want. Okay, so we're gonna just follow this is step number 1, step number 2, multiplication, step number 3, you cast. Then you're gonna get a random generated integer in some certain range. Okay, so let's try to do this. I'm gonna write it over here, and I'll clear this later, just in case you guys need it. All right.
Excuse me.
Yes.
I have a question. The system can identify scanner for some reason.
Did you import it?
Oh, yeah. I think I forgot to do that.
Yeah. Yeah, make sure you import it. Yeah, okay. So step number 1, we're gonna do double. We call it D, and you do mass random like that. Mini step number 2, we're gonna, let's just, because it's gonna be a double number, right? So I'm just gonna make it very explicitly. So you're gonna say D times 3. And mini step number 3, we're gonna say integer, I'm gonna just call that R, random number. How about random integer? And we cast it. Okay, then we got our integer, which is a random number 0, 1, 2. Okay, so now actually, why don't we just stop here, and I want to show you guys, maybe we do some system of print line, and we can actually watch how things go. How about that? So we can try to run this a few times, and you guys can see what will be the different value that this call returns to you. And so that way, I think you can remember this a little bit more. System of print line D. D. How about we do print D? We can print them all on the same line. Save some space, use some space plus D2, right? So this way it's going to print the original random number, then followed with a space, and then followed by D2. And actually, yeah. So here I'm still doing print, right? So your cursor is actually now stopping right after D2. And if I print something again, it's actually going to print right after D2 on the same line. And so I'm going to put a new space and RINT like that. Let's just run this for now and then watch the random thing actually happening. We'll clear this. Actually, you guys know that because we have input, right? That's fine. Okay. You just have to check in some input. Okay. What do you want to play? So we're gonna say rock. So these are the 3 numbers. So they generate 0.01, which is gonna give us 0. Right? As you multiply by 3 with 0.603, and you end up generate 0. Let's try again. Oh, my so this doesn't really matter. Oh, this one they generate really a small number. Oh my God, it's mine. This means like to the power of -4. This is really small. So let's generate it again. We want to see. Oh yeah, still very small. Wow. We need to see some big number. This time it's big, 0.996, almost 1, a little bit close to 1, but it's not gonna. So you got 2, and you multiply by 3, 2.8, you got 2. Right, so you guys get an idea. Let's see if we can get a 1. Oh, this time it's still 2, right? You got an idea? Very random. This time is 1. 0.4 times 3, 1 point something. You get 1. Okay. So now you guys actually seen the random generation in action now. Now we want to just somehow map the 0, 1, 2 into different play. Right? As I said, which one do you map to doesn't really matter because they're all evenly possible. So here I'm gonna say if R, this integer, random integer, is 0, then you just say, oh, okay, I'll just say if 0, then rock. Doesn't matter. Right? Then you want to say, then compute robot play will be rock. You can do something like that. But it's red because you haven't declared it yet. So you want to declare that first. You want to say car, robot play, right? You don't have to give it a value because you're gonna assign some values to that later, right after. So you can declare the robot play. Then you're gonna say, I have 3 different possibilities. If it's 0, then I'm gonna assign R to the variable. Otherwise, I have 2 more possibilities. So we're gonna use the if, else. Okay, so I say else if is 1, then I'm gonna say, just assume we play. Okay, how about that? Now you figure out, you handle the 2 scenarios first, then you're gonna have just only 1 more scenario to handle, which is the integer is 2. So you don't have to say else anymore, okay? Because you know that if the code ever comes here, it must be true. Because based on your own code, it only can be 1, 0, and 2. And so here you're gonna just say else, then go ahead to say robot play is scissors, like that. If you want to tell the user what the robot play, because later on next step will be compare, which you do the whole thing internally, right? Then you're gonna tell the user who wins, and you may be very nice to say, hey, the robot played this, so I didn't make a mistake. You did lose, or something like that, right? So you might just want to tell the user, I played, because you're the robot. So I played like that. Right, something like that. You can copy this line over here so that your code is a little nicer and user-friendly. I play paper. And here, oh guys, let me talk about something important, which is when is the curly bracket required and when is this optional. So I think now is probably a good time for me to talk about it. And you guys can see that I actually put curly bracket here and I put curly bracket here. Did you guys notice that I didn't have the curly bracket before I add a line? Right now, my code is valid and working. And you guys notice that some of them have curly bracket and some of them didn't have curly bracket. And this guy didn't have curly bracket and this guy didn't curly bracket, didn't have it. But if I want to actually also print, I print something. I also want to print something in addition to set the P to be robot play. When R integer is 1, I actually need to put a curly bracket around it. Why? Because now I'm doing 2 things rather than just 1 thing. So if under a particular condition, you only have 1 statement that is associated with a condition, then you do not have to do curly bracket. Just like what we are doing here, right? I'd say else, otherwise assign as to robot play. So I didn't have curly bracket, which is fine because I only have 1 statement that I need to execute in this scenario, in this situation. If I decided I actually want to do 1 more thing, right? Because I want to say I played scissors. Then you have to wrap this around with a curly bracket so that the whole thing is associated with the scenario. And this is very important. Why? Because based on this rule, you can figure out what code is actually associated with each condition. For example, guys, here, if my code just looks like this, without me actually wrapping around these 2 lines with a curly bracket, what do you guys think is going to happen in the else scenario? which line is actually going to be executed in the else scenario? Did somebody say something? Only this line. Okay, because Java only execute the immediately followed either one line or the block that is, make that associated with a condition. Okay, so if you didn't wrap multiple lines as within a block, then they only think you only want to associate that one immediate line after the else or after the if with the condition. Then how about line 28 then? How about my assignment over here? What do you guys think is going to happen to this 128? Now my line 28 is actually not associated with any conditions. So essentially, even though I have a tabulation here, doesn't really matter. Compiler doesn't look at tabulation, okay? So here, this whole thing is my entire conditional flow. If my code looks like this, which is incorrect, but I want you guys to understand what's going on, okay? If something, curly bracket, execute a block, else if something, curly bracket, execute a block, else no curly bracket, execute the one line. So this line 28, is actually going to be where all this condition merge back to, right? So from line 19, you may go in here, you may go in here, you may go in here, and then they all merge back, right? So this robot play is S will be executed regardless. So this will be a bug, right? If I write my code like this, that means no matter what number you randomly generate, the computer always plays scissors. Because this line is no longer belonging to any of the condition, okay? Does it make sense? Okay, so now after we finish step 3, we can take a break, right? So here I want to say system out print line play scissors. Then you know that, okay, I want to do 2 things in this scenario, so you want to wrap them within the curly bracket block. So we call this a block. More than one sentences wrap around within the curly bracket pair is called a block, okay? Now, by the way, if you have just one sentence, let's say that you do not want to print this line, you can still do curly bracket. So if you do curly bracket regardless, that will be fine. Okay, it's not like if you do one sentence, you cannot do curly bracket. Curly bracket is always fine, but it's required if you do more than one sentence. Okay. Now let's go ahead to try it. Run. And what do you want to play? Right now, whatever the user input doesn't matter because we haven't really used that. Look at it. We didn't really use the user play yet, right? So, and also we didn't use the robot play yet. And that's going to happen in step number 4, where we're going to do the comparison, right? So now, whatever you write doesn't really matter, okay? Users put play whatever and robot play rock. Say paper and robot play paper again. So inside step number 4, we're gonna be able to figure out who win, who lose. Maybe it's a tie.